what if human institutions, everything from our courts of law to like your local car dealership, what if they were never actually the goal?
Right.
Like, what if they are just temporary workarounds for the fact that we simply weren't smart enough to do things better?
That is the big question.
And here's where it gets really, really interesting. What happens when that insufficient intelligence finally gets an upgrade?
It forces, well, a complete recalculation of reality.
Yeah.
I mean, you have to look at the entire scaffolding of a modern society and ask, is this a load-bearing wall, or is it just, scaffolding that we are finally ready to take down?
Yeah, exactly.
What we are seeing right now is that the scaffolding is actually starting to come apart.
It really is. And that's exactly the bleeding edge we are exploring today on the show. We're looking at the state of the singularity as of right now, March 31st, 2026.
A very specific, very wild moment in time.
Oh, totally wild. And our source material today is the latest and frankly mind-bending Substack post from the Innermost Loop by Dr. Alex Wisner-Gross.
A brilliant piece of writing.
It is. And for those of you who follow his bold contributions on Peter Diamandis' YouTube series, Moonshots, you know exactly the caliber of insight we're dealing with today.
Oh, absolutely. The fans know it's coming.
Yeah, today's deep dive is based on his piece titled, "Our Institutions Were Just Workarounds for Insufficient Intelligence."
Which is just a profound piece of synthesis. I mean, he's connecting dots across foundational AI research, synthetic biology, orbital hardware, macroeconomics.
All the things.
All of it, in a way that very few people are even attempting right now.
But before we get into the absolute wild ride that is this material, I want to take a quick moment. If you're watching us on YouTube right now, I want to ask you to subscribe and select the ringing bell to have each new episode delivered directly to you.
It makes a huge difference.
It really does. I'll just give you a second to do that.
Ding the bell?
Right, ding the bell. We really do appreciate it. Because I recently found out that there are currently over 3 million new videos being uploaded to YouTube every single day.
Wait, 3 million?
3 million every single day. So each listen, each time you choose to spend your time with us, it's a precious moment of connection that really should be appreciated for the unlikely miracle that it is.
It honestly puts the scale of information density into perspective. You're finding a needle in a haystack made entirely of other needles.
You really are. And, as an artist with a lifelong interest in cutting-edge tools, knowing what's becoming available inspires me more than almost anything else.
The tools are changing so fast.
So fast. Knowing what is out there, just understanding the mechanics of the possible, it's the ultimate fuel for creativity and innovation. And I wanted to share this valuable fuel as I discovered it myself, like in real time.
Which is the best time to share it.
Exactly. I've always felt as much affinity with engineers and technologists as I do with artists and creatives because at the highest levels, they are doing the exact same thing.
Making the invisible visible.
Yes. Making the invisible visible. This tiny niche channel is just the result of my natural desire to share what I know. Finding others, finding you, listening right now with the mental bandwidth to absorb these new, impossible possibilities has been an unexpected and very welcome gift.
It's a great community.
It really is. Reading your insightful comments gives me new faith in humanity. It honestly feels like that moment in school when the coolest kid you've ever met sits down next to you at lunch and starts the best conversation you've ever had.
Oh, that is a brilliant way to frame it. It's a community of the curious, just navigating the frontier together.
It is. But, well, here's the catch. AI makes this channel possible, but it also increases the difficulty of natural discovery. The algorithm tends to hide content in this format because so many viewers are so against what they assume is easily generated.
Right, the algorithm has its own biases.
Yeah. Your attention is what lifts Innermost Loop discussion out of obscurity so that others might become aware of it. So if you know of anyone else who would enjoy this long-tail information, please send a link to our playlist.
Spread the word.
Please do. We've got 44 episodes so far, 38 of which feature original music by our house band, Rainbow. Finding us was a miraculous coincidence of peculiar alignment. Celebrate it with a thumbs up and strap in for today's wild ride. I'll include that link to the playlist for you in the description below.
Awesome.
Thanks for tuning in. On with the show.
I am more than ready.
Yes.
Let's look at where this dispatch begins because it starts at the very foundation of how artificial intelligence is currently evolving. It starts with the software rewriting itself.
Okay, let's unpack this. Because the dispatch drops us right into the deep end of AI agents. The premise here is that the Singularity is optimizing the optimizers.
Right.
We're looking at a massive leap in AI research agents, specifically Meta's new AIRA2, and apparently it has cracked some major structural bottlenecks that have been, holding back autonomous research.
Yes, this is a phenomenal breakthrough.
Yeah.
And to really understand the why here, we have to look at the mechanics of those bottlenecks. Historically, and by historically, I mean just a few months ago, in late 2025.
Which is ancient history in AI time.
Exactly. AI research agents were heavily constrained by something called synchronous single GPU execution.
Okay, meaning what? They could only think in a straight line, like one thought at a time on one chip.
Precisely. They were acting sequentially. They would test a hypothesis, wait for the result, process that result, and then formulate the next step.
Sounds incredibly slow.
It was painfully slow and severely limited by hardware constraints. But more importantly, they suffered from a phenomenon known as the generalization gap.
The generalization gap, I know we've touched on this before on the show, but explain how that manifests in an autonomous agent that's like trying to do complex research.
Think of it like cognitive fatigue combined with a total loss of context. If you ask an AI agent to solve a problem that takes maybe 5 steps, it performs brilliantly.
Right.
But if the research problem requires a search horizon of 50 or 100 steps, like designing a novel software architecture from scratch, the agent starts to drift.
Like it gets distracted.
Essentially, yes, errors compound. It forgets its original constraints, it hallucinates dead ends, and it ultimately degrades in performance. It just loses coherence over long stretches of autonomous action.
So it loses the plot. Like a human researcher pulling an all-nighter who suddenly realizes they've spent 3 hours reading Wikipedia articles completely unrelated to their thesis.
Exactly like that. But Meta's AIRA2 fixes this coherence issue, and the fix is structural. It's a recursive architecture they are calling bi-level auto-research.
Bi-level auto-research. So 2 levels of autonomous research happening simultaneously. How does that actually work under the hood?
Imagine an inner research loop. This is the core agent doing the actual grunt work. Writing the code, testing the math, crunching the data.
The worker bee.
Right, the worker. But wrapped around that inner loop is an outer loop. And this outer loop's entire job is metacognitive.
Okay, meaning it's watching the worker.
It observes the inner loop. It watches where the inner loop gets stuck, analyzes the failure, and then generates entirely new Python search strategies at runtime to inject into the inner loop. It's dynamically rewriting the methodology of the research while the research is happening.
Wait, hold on. Let me push back on this for a second because I want to wrap my head around it. If I'm trying to build a rocket, right, and I don't know how to build a rocket, putting on a manager hat and watching myself fail isn't going to magically teach me rocket science.
Fair point.
So if the manager and the worker are literally the exact same brain, aren't they constrained by the exact same blind spots? How does putting on a different hat allow the AI to invent a tool it couldn't see as a worker?
That is the exact right question to ask. And the answer is fascinating. It has everything to do with context windows and the nature of prompt instruction. When the LLM is acting as the worker in that inner loop, its context window is filled with the immediate granular details of the code it's writing. It is deep in the weeds. It literally cannot see the macro strategy, because its attention mechanism is entirely saturated with micro-level syntax.
It's too close to the canvas.
Exactly. When you invoke the outer loop, you are giving the LLM a completely different prompt and a clean context window. The prompt says, look at this transcript of a worker failing. Identify the conceptual flaw in their approach and write a Python script that forces them to search a different mathematical space.
Oh, wow.
The LLM isn't magically getting smarter. It's escaping its own context trap by shifting its attention mechanism from execution to critique and strategy. And because it's powered by the exact same underlying weights, there's no loss in translation between the manager and the worker.
It's just a perfectly self-contained bootstrapping improvement mechanism.
Right.
That is wild. So it's not that the brain is different, it's that the perspective applied to the problem is radically shifted. And to make this even more accessible, there's a mention in the source material of natural language agent harnesses.
Yes, this is crucial for the scaling of these systems. Historically, the control logic of an agent, the deep rules governing how it behaves, how it utilizes tools, how it structures its memory, that was all buried in highly complex Python or C++ code.
Stuff the average person could never touch.
Exactly. The harness was rigid. Now, they have externalized that control logic into portable, editable natural language artifacts.
Meaning I could literally open a text document and read the AI's core operating philosophy in plain English.
Yes, and you can edit it. You can change a sentence in an English paragraph and radically alter the foundational search parameters of the AI agent. The harness itself becomes a first-class programmable object.
But, I mean, if these agents are dynamically rewriting their own code and reading English philosophy documents to guide their research, how do we even measure if they are actually getting better? The old benchmarks, like having them take the SATs or the bar exam, they seem totally irrelevant now. We need to know if they can actually do things in the real world.
Which is why the introduction of the WR-Arena is so significant here. The old benchmarks were static. WR-Arena is designed specifically to benchmark dynamic world models.
Okay, how does it do that?
It tests three core things. First, action fidelity. Basically, does the digital action the agent takes perfectly map to the physical or computational reality? Second, long horizon forecasting. Yeah. If the agent takes an action now, can it accurately predict the cascading consequences 1,000 steps into the future?
Wow, 1,000 steps.
Yeah. And third, simulative reasoning. Can it hold a complex, chaotic environment in its latent space and manipulate it accurately?
And the results coming out of these new benchmarks aren't just theoretical. There's a specific, tangible data point here that completely blew my mind. They ran a controlled experiment during a hyperparameter search.
Which, just for context, is usually a brute force mathematical optimization process. It's essentially guessing and checking thousands of variables to find the most efficient way to run a model.
Right. It's just grinding math. But instead of just brute forcing it, they gave this auto research agent access to human-written computer science papers. The AI actually read the literature, understood the theoretical concepts the human researchers were debating, and then applied that knowledge to tune its own parameters.
And the result improved by exactly 3.2%.
3.2%.
It is astounding when you really internalize what that means. The AI is reading human academic literature to figure out how to rewire its own brain more efficiently than pure mathematics could achieve.
It's leveraging human theoretical reasoning to optimize its artificial neural network.
That is the literal definition of the singularity optimizing the optimizers.
It really is.
Yeah.
But, while this open collaborative bootstrapping is happening in some circles, there is a massive geopolitical shift happening in the background that we have to talk about. Alibaba's new Qwen 3.5 Omni model.
This is a vital data point for understanding the global landscape right now. Qwen 3.5 Omni is an absolute powerhouse. It's a natively multimodal system. It doesn't just translate audio to text, process the text, and then translate it back.
It does it all at once.
Yes, it processes text, images, video, and over 10 hours of audio natively, simultaneously, in the exact same latent space.
10 hours of audio, just the context window required to hold 10 hours of audio and reason across it accurately. That is staggering.
It really is. But the technological achievement isn't even the most important part of the story. The catch is how it's being released. It's only available via a proprietary API.
Which is a massive pivot because for the last 2 years, the Chinese tech giants, Alibaba, Tencent, Baidu, they were aggressively pushing open source models.
They were. They were flooding the zone, trying to commoditize the model layer to undercut Western AI labs.
Right, using open source as a weapon.
Exactly, an asymmetric weapon. But Qwen 3.5 Omni marks a very quiet, very deliberate retreat from that strategy. When a model becomes this powerful, when it can ingest 10 hours of continuous video and audio, cross-reference it, and reason about it strategically, it crosses a threshold.
It goes from being a useful tool to a strategic national asset.
Precisely. They are locking it down behind an API where they control the compute, the access, and the oversight. It tells us that the frontier of multimodal intelligence is accelerating so fast that the geopolitical game theory is literally shifting in real time.
Man. So we have AI rewriting its own brain, using human literature to bootstrap its intelligence and becoming a lockdown strategic asset. But an infinitely smart brain is useless if it's trapped in a server farm. If intelligence is scaling digitally, how does it spill over into the physical world?
Well, this is where the digital abstraction ends and visceral reality begins. We are moving from the realm of software directly into biology, advanced hardware, and massive physical megastructures. The digital mind is, quite literally, building hands to manipulate the physical world.
Let's start with biology, because the financial stakes here are staggering. Eli Lilly just struck a $2.75 billion deal with Insilico.
Billion with a B.
2.75 billion. That is not a small pilot program to test the waters.
Not at all. Insilico is a pioneer in end-to-end AI drug discovery. This deal is designed to bring AI-developed drugs straight to global markets. And the phrasing used in Dr. Wisner-Gross's dispatch here is perfect. He says it proves that the physical wet lab is now downstream of the weights.
Downstream of the weights. I absolutely love that phrase. We usually talk about the weights as just the neural network parameters, but explain what downstream actually implies in a pharmacological context.
Well, for the entire history of modern pharmacology, drug discovery was a physical process first. You synthesize thousands of chemical compounds in a highly expensive physical wet lab. You test them physically in petri dishes, then in animal models, then in humans, and you just hope one works without toxic side effects.
It's incredibly slow.
Phenomenally expensive, and mostly involves failure.
It's literally trial and error with pipettes and beakers.
Right. But when the wet lab is downstream of the weights, the entire paradigm flips. The AI model, the digital weights, simulates the molecular binding. It predicts the toxicity. It navigates the complex protein folding and designs the perfect molecule entirely in a digital simulation.
Wow.
So by the time a human actually synthesizes the physical molecule in a wet lab, the discovery is already finished. The physical lab only exists to manufacture the product the AI has already perfected.
So the digital mind leads, and physical reality merely follows instructions.
The physical world becomes a printer for the digital mind.
A printer for the digital mind? That is crazy. But to run simulations of that magnitude, simulating molecular physics at scale, you need a complete revolution in hardware. We can't just keep building slightly smaller silicon transistors. And that brings us to the hardware sorcery coming out of the University of Michigan, the Bismuth selenide memristor.
This is a fundamental reimagining of computing architecture.
Yeah.
And to understand why this is a breakthrough, we have to look at the flaw in how computers currently work, which is the von Neumann architecture.
Right, the separation of the processor and the memory.
Exactly. In traditional computing, data is constantly being shuffled back and forth between the CPU where the math happens and the RAM where the data is stored. That shuffling costs a massive amount of time and generates a tremendous amount of heat, which costs power. A lot of power. A memristor, which stands for memory resistor, solves this. It's a single component that regulates the flow of electrical current, and it remembers the exact amount of charge that has previously flowed through it, even when the power is turned off.
So the math and the memory are happening in the exact same physical location, which is exactly how biological brains work. Like, our neurons don't send a memory to a storage lobe to be retrieved later. The synapse itself is the memory and the processor.
Precisely. We are essentially building artificial synapses.
Mm.
But the bismuth selenide part is what makes this specific memristor revolutionary. It combines long-term memory retention with analog tuning.
Analog tuning. Why is analog important here? I thought the entire point of the digital revolution was moving everything to zeros and ones. Why go backward to analog?
That is the beauty of it. It isn't going backward, it's ascending to a more efficient state. Digital is binary. A transistor is either completely on or completely off, 0 or 1.
Right.
It's like an orchestra where the musicians can only play at maximum deafening volume or dead silence.
Ah, that is a great analogy.
But biological intelligence is analog. It exists on a continuous spectrum of signal strengths. Analog tuning in a memristor allows the circuit to act like a dimmer switch rather than an on-off switch. It can represent multiple states, fractional states, not just 0 and 1.
So the musicians in the orchestra can play with dynamics.
Yes. And it takes radically less energy to represent highly complex mathematical weights, allowing for much denser, much more energy-efficient AI models.
So we're essentially forging biological architecture out of exotic metals. And speaking of manipulating physical matter in ways that defy common sense, there is a note in the source about data storage at the nanoscale. Scientists have created a microscopic QR code that has been certified as a world record for being smaller than most bacteria.
It's a stunning demonstration of physical control.
It's only visible under an electron microscope.
At the nanoscale, information density is literally becoming indistinguishable from sorcery. We're etching complex, readable data structures onto a canvas smaller than a single biological cell.
I just want to pause and point out the sheer scale of the contrast we are dealing with here. On one hand, we have microscopic QR codes smaller than a bacteria, and on the other hand, we have a massive, explosive, planetary-scale infrastructure build-out happening to support the compute necessary for this intelligence.
The compute build-out is happening on every conceivable axis: land, sea, and space.
Let's look at you at first. Mistral. which has firmly established itself as the European AI champion, just secured $830 million in debut debt financing.
That is a ton of money.
And that capital is being immediately deployed to build massive NVIDIA-powered data centers across the entire European continent.
And they aren't just building these for civilian enterprise use. The dispatch notes that the French Army signed a 3-year contract with Mistral to fine-tune models specifically on defense data. The military-industrial complex is officially integrating with the AI industrial complex. It's inevitable convergence. When intelligence is the primary strategic asset, national defense becomes fundamentally tied to compute power. But perhaps the most sci-fi element of this entire infrastructure boom is happening above our heads. A company called StarCloud just hit unicorn status.
$1.1 billion valuation, right out of Y Combinator, off a $170 million raise. And their mission, building data centers in orbit.
Yes.
Now, I have to push back on the physics and economics of this. Space data centers sound incredible, but launching server racks into low Earth orbit is insanely expensive. It's thousands of dollars per kilogram. And what about the latency? If I query an AI and the data has to travel up to a satellite and back down through the atmosphere, isn't that a massive bottleneck?
It is a bottleneck for real-time inference, yes. If you're asking a chatbot to write an email, you don't want to route that through orbit. But StarCloud isn't built for inference. It's built for training.
Ah, the massive asynchronous training runs that take months to complete.
Exactly. Training a frontier model requires hundreds of thousands of GPUs running at maximum capacity for months, which requires a staggering amount of electricity and generates enough heat to melt a small city. We are literally running out of room on the power grid here on Earth to cool these facilities. In space, you solve both problems simultaneously.
Because space is a vacuum, so it's freezing, and you have unfiltered access to the sun.
Yes. You use continuous, unfiltered solar power to run the arrays, and you use the ambient vacuum of space to manage the thermal load. The data goes up once, the model trains for 3 months, and the finished weights come down once. The latency doesn't matter.
That is so smart.
It shows how desperate the thermodynamic need for compute has actually become. It is now economically viable to launch servers into the void.
Which perfectly explains the next data point. If space is one frontier for massive compute, the deep sea is the other. China just launched the world's first ultra-large deep-sea floating research island in Shanghai.
A deep-sea floating research island. I mean, it sounds like something out of a science fiction novel, but it's a massive logistical hub. It's designed to extend the frontier of energy harvesting, compute capacity, and oceanic research far into international waters, completely bypassing terrestrial grid limitations.
The physical footprint of intelligence is aggressively expanding outward.
It is.
So from space stations harnessing the sun to deep-sea islands tapping oceanic energy, we're building the physical environments for superintelligence. But what about the physical actors moving within these new environments? That leads us directly into the third major theme of the piece. Robots as the physical operating system.
This is a crucial distinction that people really need to internalize. We're very used to thinking of robots as single-purpose machines, a robotic arm that welds a car chassis, a Roomba that vacuums a carpet. But an operating system is fundamentally different. An OS is a general-purpose platform that manages hardware and software resources to execute any arbitrary task.
Right. Windows or macOS doesn't just do one thing. It's the invisible layer between your intent and the computer's physical execution. You're saying robots are becoming the translation layer between digital intent and the physical world.
Exactly. And the dispatch gives us incredible concrete examples of this happening at scale.
Yep.
First up is Skilled AI. They recently demonstrated their robotic brain autonomously assembling GPU racks with incredible precision.
Okay, I need everyone to stop and think about the loop happening there. You have AI models running on GPUs, figuring out the spatial reasoning required to control physical robotic arms so that those robotic arms can physically assemble more server racks filled with more GPUs to train more powerful AI models.
It is the ultimate Ouroboros of physical infrastructure.
Robots are literally building the data centers that will train the next generation of robots.
The system is expanding itself, and the dexterity of these systems is advancing incredibly fast. Just look at Figure 03. This is a humanoid robot, and it was just shown autonomously sorting deformable packages, orienting the labels perfectly face down for a scanner.
Now, to a layperson, sorting packages sounds like the most mundane task imaginable. Why is this a breakthrough? I assume deformable is the key word there.
Absolutely. Traditional robotics rely on rigid physics. A metal block or a cardboard box is easy for a robot to grab because its center of mass is static and its geometry is predictable.
Right, it doesn't change shape when you touch it.
But a deformable package, like a soft poly bag containing a t-shirt, is pure physical chaos. It crinkles, it folds, the center of gravity shifts dynamically the moment you touch it.
It responds to the robot's touch by changing its physical properties.
Yes. For a robot to look at a chaotic, deformable shape in real time, identify where the barcode label is hidden in the folds, grasp it with exactly enough force not to tear it but firmly enough to control it, and then orient it perfectly for a scanner. That requires an incredibly sophisticated simulative world model.
Wow.
The AI mind inside the robot has to intuitively understand physical reality, the same way a human toddler learns how gravity and friction work.
It has a fundamental intuition for physics, and they're scaling that intuition to massive industrial tasks. The dispatch mentions the Maximo robot, which just installed 100 megawatts of solar power at the AES Belfield complex.
100 megawatts. We aren't talking about a robot doing a cute backflip in a laboratory. We are talking about utility-scale infrastructure deployment. Lifting heavy panels, aligning them perfectly on uneven terrain, bolting them down, all entirely automated by physical agents.
But this integration isn't just happening in closed industrial zones. It's bleeding into everyday societal integration, and some of it feels, well, quite dystopian. The dispatch points out that robotic security dogs are now actively patrolling the streets of Atlanta.
Yes. Residents and neighborhood watch groups are literally purchasing or leasing autonomous quadruped robots to take crime prevention into their own hands. They have thermal cameras, they patrol specific perimeters autonomously, and they stream data back to the residents.
Which is fascinating. Neighborhood watch replaced by robot hounds. But it highlights how quickly everyday people will adopt these physical agents if they perceive a failure in traditional institutions, like public safety, which ties perfectly into the core thesis we'll get to in a moment. But first, we need to talk about Mark Cuban's prediction versus present reality.
This is a great philosophical contrast. Mark Cuban recently made a very bold prediction. He argued that humanoid robots, robots that look like us with 2 arms and 2 legs walking around our houses doing our chores, won't be needed beyond the next decade. His argument is that the robots will simply merge into their environments.
Wait, so less walking metallic butler and more that the kitchen itself becomes the robot, like ambient computing, but ambient physical robotics.
Exactly. Why do you need to manufacture a highly complex humanoid robot to walk over, open your fridge, grab a beer, and hand it to you if the fridge itself is intelligent, track-mounted, and can simply dispense what you need?
That's a good point.
Why do you need a robot to sit in the driver's seat of your car and turn the wheel if the car is a robot? Cuban is arguing that embedding the physical intelligence directly into our environments is far more efficient than building an artificial human to interact with dumb environments.
That makes total sense from an engineering perspective. Why build an artificial hand to turn a dumb doorknob when you can just make the door smart? And we are already seeing the immediate life-changing beneficiaries of this environment as robot paradigm right now. The dispatch points out that 93-year-olds are finding completely new freedom. They are using Tesla full self-driving and Grok navigation to drive without the fear, the delayed reaction times, or the fatigue that currently comes with advanced age.
The car is the robot. The environment accommodates the human. It's a beautiful example of technology restoring human agency where biology has degraded it.
It really is. It gives mobility back. So as robots seamlessly merge into the physical environment, coding and software creation are seamlessly merging with pure human intent. And that brings us to the fourth major theme. The dispatch calls this the vibe-coded flood.
Vibe coding. It's such a perfect colloquial term for a massive paradigm shift. We are moving entirely away from syntax and moving toward pure intent.
Exactly. You don't need to know Python or C++ or JavaScript anymore. You don't need to know where the semicolon goes. You just need to be able to articulate the vibe of what you want, like the business logic, the user experience, the ultimate goal, and the agentic AI writes, tests, and deploys the code. And the result of this frictionless creation is an absolute flood of software.
The dispatch notes that U.S. iOS app releases grew 54.8% year over year in January 2026.
That's huge.
As the highest growth rate in 4 years. The barrier to entry for software creation has dropped functionally to 0. If you can speak your intent clearly, you can deploy complex software.
But what is truly fascinating here is how these coding tools are now interacting with each other. They aren't just taking human instructions, they are nesting. The dispatch mentions that OpenAI just introduced a Codex plugin for Claude Code.
Let's break down why that is so significant. You're an end user, and you are using Anthropic's Claude to architect your software. But through this plugin, Claude can autonomously invoke OpenAI's Codex model to review a specific module of the code, or delegate a subtask that Codex happens to be better at.
You're using one artificial intelligence to manage, audit, and direct a rival artificial intelligence.
Exactly. It's a marketplace of synthetic cognition. You're building complex supply chains of thought, completely abstracted from human intervention. The AIs are hiring each other to complete your vibe-coded project.
And while our software is booming and writing itself, the wearable layer that connects our physical bodies to this software is scaling right alongside it. The biometric health wearable company just hit $1 billion in annual recurring revenue.
Wow.
Yeah, they raised $575 million at a $10.1 billion valuation. We are constantly streaming our physical state, our heart rate, our sleep cycles, our strain into these agentic systems.
Which brings us to the absolute core theme of this entire deep dive. The title of the piece and the unifying theory behind everything we've discussed today, the obsolescence of institutions.
Oh.
His premise is provocative, but when you look at the data, it is incredibly compelling. Our institutions were just workarounds for insufficient intelligence.
Let's really dig into this because this is the aha moment of the whole piece. He's saying that things like the legal system, regulatory bodies, and dealership networks didn't exist because they were the optimal way to organize society. They existed because human intelligence couldn't scale efficiently enough to handle complex, high-friction interactions on a one-to-one basis.
Let's take his example of a court of law. What is a court? At its core, a court is essentially a very slow, very expensive, human-powered algorithm for resolving disputes and determining truth.
An algorithm made of people.
Right. It requires a judge, a jury of 12 peers, opposing counsel, complex rules of evidence, and months of preparation. Why? Because human memory is fallible. Because human judgment is inherently biased, and because processing the sheer volume of facts takes immense cognitive labor.
So the institution is a workaround for the fact that a single human cannot instantly process all the evidence impartially.
Exactly.
Yeah.
But what happens when intelligence is infinite, unbiased, perfectly retentive, and instantaneous? The institution starts to look less like a pillar of society and more like an outdated, incredibly inefficient workaround.
And we are seeing the friction of this collision right now. The dispatch points out that Philadelphia courts just banned all smart and AI-integrated eyewear from their courtrooms. Why? Explicitly to prevent witness and juror intimidation.
Think about the mechanics of what they are banning. Imagine a juror wearing AI glasses. The glasses are constantly analyzing the micro-expressions and pupil dilation of a witness on the stand.
Oh.
It's cross-referencing their spoken testimony with every public database, every text message, every geological ping of their cell phone in real time. And it's whispering a probability score of deception directly into the juror's ear.
The AI is acting as an omniscient lie detector.
Yes. If a juror has access to that level of synthesized intelligence, the entire foundational premise of a human jury trial is subverted. The lawyers can no longer manipulate the narrative. The judge can no longer control what evidence the jury considers. The institution cannot handle the intelligence upgrade, so it bans the intelligence to preserve its own relevance.
It's trying to hold back the tide. The workaround is fighting the upgrade. And we see the exact same mechanic happening in commerce. Rivian, the electric vehicle manufacturer, just won a years-long battle against Washington state car dealers. Rivian wanted to sell their cars directly to buyers. The traditional car dealership network is the ultimate workaround institution.
Historically, yes. Dealerships existed because 50 years ago, a manufacturer in Detroit couldn't physically handle the logistics of local sales, financing, trade-ins, and maintenance in every small town in America. They lacked the intelligence and logistical bandwidth to do it at scale. So they created the institution of the franchise dealership to handle the local friction.
But with AI managing hyper-efficient supply chain logistics, predictive maintenance happening via over-the-air software updates, and direct-to-consumer digital financing handled by algorithms, the middleman, the dealership institution, becomes dead weight. The manufacturer has the intelligence to scale, so the workaround is bypassed.
We see that massive logistical scaling completely bypassing old institutions with Amazon too. The dispatch mentions they are building 40 to 50 delivery hubs a year. They are literally on pace to be able to ship to every single US ZIP code within 4 years.
They are replacing the institution of the U.S. Postal Service. The USPS had a monopoly on final mile delivery because it was a government-subsidized workaround for the immense difficulty of reaching rural addresses. Amazon is bypassing that institution with sheer AI-optimized logistical brute force.
Now, we need to transition to perhaps the most sensitive and consequential area where this institutional workaround theory is playing out.
Yeah?
Politics.
Yes. Now, I want to be incredibly clear here, directly to the listener, before we dive into this data point. This is a critical rule for us on the show. Whenever we touch on political operations or PCs, we are not taking a side.
Important disclaimer.
Extremely important. We are not endorsing any viewpoint, we are not endorsing this specific pay, and we are not endorsing the White House. We are strictly and impartially reporting on this as a data point to understand the machinery of how AI is reshaping institutional power mechanics. We're just looking at the gears turning.
Absolutely. The geopolitical and domestic data point the dispatch brings up is a pro-AI political operation called Innovation Council Action. They are pouring over $100 million into the midterms, specifically to push AI deregulation, and they are doing it with the explicit blessing of the White House.
So, impartially looking at the mechanics of this, why is this significant to the point about institutions being workarounds?
It is significant because political lobbying, congressional hearings, and regulatory frameworks are historically incredibly slow, bureaucratic institutions. They are designed to manage the pace of societal change through deliberation. But here we have a massive injection of capital, $100 million, specifically aimed at bypassing traditional regulatory friction.
It's accelerating the process.
It is the technology sector utilizing raw, concentrated political machinery to ensure that the older institutions do not bottleneck the deployment of new intelligence. It's the obsolescence of traditional regulatory speed limits.
The new intelligence refusing to be slowed down by the old workarounds. It's fascinating. Applying this framework to things outside the dispatch is wild, too. Think about the institution of modern dating apps, or even the traditional university structure. Is a 4-year degree just a workaround because we didn't have a way to perfectly, instantaneously, algorithmically verify a person's skill and competence in real time?
That is an excellent application of the theory. If an AI agent can perfectly assess your coding ability, your critical thinking, and your temperament in a 10-minute interaction, the institution of the university diploma as a signal of competence loses its value entirely. The institution is bypassed by direct measurement.
It changes everything. And it isn't just happening in law, commerce, and politics. It's happening in culture. The dispatch points out that Midjourney's monthly traffic has fallen 60% since its peak in 2023.
Now, a superficial analysis of that metric would lead someone to say, oh, look, AI art is a fad, the bubble burst, people are bored of it, but that is a complete misread of the data.
Exactly. It's not that AI art is dying, it's that it has been completely commoditized. It's now just a baseline feature of all foundation models. You don't need to go to a dedicated destination site or a Discord server like Midjourney when image generation is just baked into your phone's operating system, your word processor, and your social media app. The dedicated institution of the AI art generator site is obsolete because the capability is simply ambient. It's everywhere.
It dissolves into the environment, exactly like Mark Cuban predicted with the physical robots. It becomes the water we swim in. And perhaps the most visceral cultural example of this acceptance comes from the world of sports. The dispatch mentions Dana White, the CEO of the UFC. He was recently asked by a sports reporter about the UFC's extensive use of generative AI in their promotional materials.
And his response was legendary. He literally told the reporter to shut up and watch the fights.
Which is a profound, if blunt, statement on the cultural acceptance of these tools. The institution of media critique, the agonizing over the ethics of AI generation, the hand-wringing over authenticity. Dana White is reflecting a massive silent portion of the populace that simply doesn't care about the philosophical debate.
They really don't.
If the tool improves the product, the end user accepts it. The institutional gatekeeping of how things should be made is being completely ignored by the mainstream.
Shut up and watch the fights. It is the ultimate vibe check on the Singularity. The masses don't care about the plumbing, they just want the water. Okay, so we've scaled from microscopic quantum QR codes all the way to global supply chains, massive political lobbying, and cultural shifts. There's really only one place left to look to grasp the scale of this. Up.
This brings us to the final observation in the dispatch. Cosmic fireworks and the need for speed.
The dispatch ends by looking at the sky. NASA's Artemis II launches on Wednesday. We are finally sending humans back to the moon for the first time in 50 years.
It's a monumental human achievement, a return to our highest physical aspirations. But the author beautifully juxtaposes that human achievement with a cosmic coincidence happening right now. The American Meteor Society is reporting an unprecedented concentration of major fireballs in the sky in the first quarter of 2026.
As if the cosmos itself is providing the fireworks early to celebrate. I love how the dispatch framed that. Even the meteors are accelerating now.
It's a poetic metaphor, but it perfectly captures the psychological feeling of living through this exact moment in history. The sheer velocity of technological change across software, biology, robotics, and macro institutions makes it feel as though the very fabric of reality, the cosmos itself, is matching our speed. The acceleration is total, and it is inescapable.
And you can feel that acceleration in the community's reaction to this post. I love reading the Substack comments because it grounds all this high-level theory. User Steve commented that the title of the piece, the idea that the economy is discovering its institutions were just workarounds, he called that the AWG understatement of the year.
Steve is entirely correct. It is an understatement because the implications of that single sentence are so vast that it threatens to upend centuries of social contract. A single sentence can barely contain the disruption it implies.
And then user Darat Chowdhury joked that they saw the notification, repeatedly refreshed their Substack app, and actually needed to listen to Alex read it out loud at 1.75x speed just to comprehend it all.
That is the modern condition encapsulated. We literally need to consume information about the acceleration at an accelerated pace just to keep our heads above water. Which is exactly why Dr. Wisner-Gross's recent roadmap book, Solve Everything, co-authored with Peter Diamandis, is so crucial right now. When the workarounds fall away, we need blueprints for what to build next. We need to know how to aim this singularity.
We really do. We need guides, we need maps, and we need each other to process it. And that brings us to the end of this incredible dispatch. But before we sign off, I know you always have one last thing for us to chew on. You always take the macro and make it personal.
I try to. We spent this entire deep dive exploring this brilliant premise that human institutions were just workarounds for insufficient intelligence. We talked about massive macro institutions, courts of law, dealership supply chains, the postal service, universities. But I want to leave you, the listener, with a final provocative thought. If our macro institutions are just workarounds, what happens to our micro institutions? What happens to human relationships?
Whoa, wow, okay.
Think about it. Will we find that the way we currently connect, the way we clumsily communicate our needs, the way we resolve interpersonal conflict, are those also just biological workarounds waiting for a higher intelligence upgrade?
That's a huge question.
When you have a personal AI agent that understands your emotional state, your trauma, and your triggers perfectly, and it can communicate instantaneously with your partner's AI agent to resolve a misunderstanding before a single angry word is even spoken out loud, does the institution of human conflict become obsolete? Do we outsource our emotional labor to the singularity? It is something to seriously mull over.
That is incredibly heavy. Are the fights we have with the people we love just workarounds because we don't have the bandwidth to perfectly articulate our inner state? I'm going to be thinking about that all week. Are we just biological workarounds? That is exactly why you are the expert here.
Just giving everyone some homework.
Well, that is all the time we have for today's wild ride. Our outro music, as always, is by R41NB0W, the best band in the universe.
They truly are.
For those of you who might be new and don't know the lore, they are our 6 gynoid artists in residence based in Bavet, Cambodia. Today's song is called Asan Air, which translates to Fire with Fire. And what is truly amazing, what ties this all together, is that all of Rainbow's finished songs are performed live for the Innermost Loop discussion by the virtual band's creator. They use the 4x4 KU5 platform, and I absolutely love their tagline. It feels so relevant today. Human performance in the age of AI, reclaiming your humanity from the algorithm.
A perfectly fitting end to today's topic. We're tearing down the workarounds, but we must reclaim our humanity in the process.
Absolutely beautifully said. I'll include more information on today's song and on Abacus in the video description below. Thank you for joining us on this deep dive. Keep questioning the workarounds. We'll see you next time.